All right. So in this section here, we're going to kind of show to ourselves or prove to ourselves three different kind of rules of logarithms. And I think the first two will make a lot of sense. The third one might be a little bit tougher, but once we get into the examples for it, I think you'll get a good grip of it. So the first one is, well, if I have log of some base b uh, of 1 equals, well, what is the exponent going to have to be? Now, I think of if I ever have a number um, to some power, so let's say 35 to the x power is equal to 1, what does x have to be? And think through that, and it's going to be 0. Anytime you have a number to a 0 as the exponent, our answer is 1. And maybe if you can think back to exponents, you can remember that hey, if we had x squared divided by x squared, this is, well, it's divided by itself, so it's got to be 1. But at the same time, if we subtract our exponents, since we're dividing, this is x to the 0. And how can x to the 0 be equal to 1? Well, it's just kind of by definition that something to the 0 power does equal 1. So here's kind of our first rule. And that one hopefully makes a little bit of sense. That if we have log, it doesn't matter what the base is, of 1, then our answer has to be 0. Our second rule, and that's kind of that one, that's rule number 1 there, I guess. Our second rule is going to be that if we have log base b of b to some power, then that answer has to be the power. And that hopefully makes sense. If I'm saying that log base 3 of 3 squared, what would the exponent be if the base was 3 and it was squared? Well, the exponent's right there. It's not really much of a trick question. The exponent has to be 2. And so if we have the same base of our answer, then the exponent is what our result is. And hopefully that makes a little bit of sense as well. The third rule, I'm going to kind of hold off for right now. We'll get to this probably in the next video. This section is going to get broken up into a couple of different videos. But as we get to it, I think you'll get a good grip of that one as well. So let's kind of put these into practice. Here we have log base 8 of 2. And so if I were to write this in exponential form, and let's kind of just set it equal to x just for helpful purposes, because we're trying to figure out what would the exponent be if the base was 8 and it was equal to 2. Well, let's see that that 8's had to get smaller, and hey, 8, we can rewrite 8 as 2 to the third power, right? 2 to the third power. Oops. 2 to the third power. So the x equals 2. And so if we're thinking through this, what would x have to be? Well, x would have to be 1/3 to kind of counteract that 2 to the third power. And so we've got our answer in this one is going to be x equals 1/3. And maybe another way to think about that as well, and really there's no, we wrote in the x, so let's actually just change that too, because it's not really an equation. But x is going to be equal to 1/3 if we had an x. So just 1/3 is our result, is our value. And another way to think of that would be kind of using our second rule here, that log, let's rewrite that, log base 8 of 8 to the 1/3, because that's just 2, right? 8 to the 1/3 we just showed was 2. So then our result is just that exponent. That's what we're looking for. So to the 1/3. All right, problem 2 here. We've got the natural log of 1 over e cubed. And so let's take a look at this. This is really ln, and actually let's get the darker green here. ln, the natural log, which again the base is e. So that of, and we can rewrite this part here is really e to the negative third if I were to keep e in the numerator. So log base e, the natural log, of e to the negative 3. Now that's the same rule again. We've got e and e. So if we have the same base as our result, and then we're looking for the exponent. What is the exponent there? Well, it's negative 3. There's our answer on B. C, and then we'll go ahead and end this video. We've got log, and there's no base written there, so think to yourself, what is that base? And yeah, it's the common log. That's a base of 10. So this is really log base 10 of 10 to the, well, this is 10 to the negative third. 10 to the negative third. And so what is our exponent here? And our exponent is negative 3. So notice kind of what we did on all three of these problems right here. We rewrote what our result was, the of, so log base 10 of 0.001. We wrote it in terms of the base because that allowed us to jump to just the exponent itself where it became a little bit more clear. All right, hope that helps, and then we'll come right, so the next video we'll go through D, E, and F. Hope this is helping.